Right, chapter number 5, statistical inference, right? So, as introduction, inferential statistics refers to drawing conclusion about uh, some characteristic about the population. So remember, we already gone through the definition of statistics last lecture, and we know that there are two type of statistics, right? First, first type is descriptive statistics. Another one is inferential statistics, right? So descriptive statistics, we already looked at last lecture, is actually intend to describe the data based on sample, right? But for inferential statistics is we want to draw a conclusion, right, from the population and infer back to the population. We want to draw a conclusion from a sample and draw back to infer back to the population, and it is based on the a random sample from that population lah. So inferential statistics utilize sample data to make estimation, prediction, decision about the population, right? So for example, let's say you want to know uh, how many cigarette to take, consume, berapa banyak cigarette yang you kena you ambil untuk mengetahui berapa risk you akan dapat heart disease, contoh kan. So you buat linear regression, right? Let's say this is one of the method lah in the inferential statistics. You do a linear regression correlation analysis, right? From a sample, and then you infer back to the population. So let's say you take 2 cigarette in the day, so will result very high risk in heart disease. So for example, right? So statistical inference incorporate estimation of population parameter, right? So dia akan kita akan consider population parameter and hypothesis testing. So in this chapter, we are trying to do a hypothesis testing. So hypothesis testing is a procedure based on sample variance, sample evidence, and the probability theory to determine whether the hypothesis is reasonable statement. For example, let's say we want to know, kalau kita tengok chapter number 5 ni, kita tengok muka surat, muka surat 82, right? Muka surat 82 dia kata, a fast food restaurant claim that customer order will be served within 8 minutes. So we want to know whether the customer will be served in 8 minutes or less or more than 8 minutes. So this is going to be our hypothesis, and then we're going to collect the data, and we want to test whether the statement the restaurant manager ni kata customer will be served within means 8 minutes or less, ataupun sebenarnya dia berlaku lebih 8 minit. So kita nak tengok sama ada statement tu betul tidak, right? So in hypothesis testing, is applied to determine whether the sample does or does not support the statement, as I said before lah, right? We want to test whether the statement given is supported or not supported based on data, right? So it involves evaluating two complementary statements. So we have two statements in hypothesis. The first statement is null hypothesis, which is H null. Another one is alternate hypothesis, which is H1 or HA lah. Or sometimes kita kata H null will represent null hypothesis. H1 or sometimes dalam buku lain dia kata HA will represent alternate hypothesis. Right? So we have two statements in hypothesis testing. First is null hypothesis, another one is alternate hypothesis. Null hypothesis is the statement that we want to test, right? Let's say kita tengok page number 82, example number 5.1. So dia kata dekat sini, a fast food restaurant claim that customer order will be served within 8 minutes. Meaning that the mu is less than or equal to 8, right? Means that the mean of serving time less than 8 minutes. So this is the statement, original statement that we want to test. So the alternate hypothesis, maksudnya the opposite way, right, of less than 8 minutes should be mu more than 8 minutes lah. So kalau testing this is the first null hypothesis yang kita statement yang kita nak test ni is not true, is going to be the other way lah, means more than 8 minutes, right? So this is the concept of hypothesis statement, right? So ada soalan tak berkaitan kat sini? If you don't understand about the null hypothesis and alternate hypothesis, ada soalan?
So far tak ada.
Alright, good. So I hope you understand. In hypothesis testing, we want to test whether the statement is true or not based on the sample data. And from the conclusion dekat kita dapat dekat hypothesis testing ni, kita akan infer back to the population. Right? So in hypothesis testing, we have two statements. First is null hypothesis, which is H null. The notation is H null. And another one is the opposite of null hypothesis is alternate hypothesis. Right? Null hypothesis is the statement that we want to test. Right? Alternate hypothesis is the opposite way. Kalau statement yang kita nak test tu tak betul, means that it should be another way lah, opposite way lah, which is alternate hypothesis. Right? So now let's look at the step in the hypothesis testing procedure. Right? So this one I took from page number 79. Right? We have four steps actually. First step is we need to formulate the hypothesis test to stating the null and alternate hypothesis. First step is we need to state the statement. What is the null hypothesis and what is alternate hypothesis? Right, this is very important. Let's say we want to test whether the restaurant can serve the customer within 8 minutes, means mu less than or equal to 8 minutes. The alternate way means kalau testing ni tak betul, the opposite way is it should be more than 8 minutes lah. Right? And then nanti I terangkan lebih lanjut berkenaan dengan tail kat sini. Right? And the second step is we need to select a level of significance. Level of significance usually on social science, right? We take alpha equal to 0.05. So level of significance would represent type 1 error. Right? Type 1 error ni apa maksud? It means that the error that we reserve for calculation. So there are no perfect calculation, there are no perfect conclusion or decision, right? We should reserve some errors or making incorrect decision. So the errors that we want to reserve is we want to basically kita nak ambil yang minimum error, right? So maksudnya kalau kita buat kesilapan pun, kesilapan tu sangat-sangat susah nak berlaku. So normally in statistics we need to calculate the type 1 error, but usually in social science we are taking 0.05. If you are doing clinical studies, right, normally they are taking 0.01, means that we have 95% confidence that our decision is correct, and we reserve 5% for incorrect decision. Right, means that the result yang kita akan calculate nanti dalam hypothesis testing ni, right, kita 95% confidence that this result is correct, and only 5% sometimes the result will be incorrect result. Apa maksud incorrect result? Incorrect result means that sometimes I letak tepi Sekejap. Sometimes dia ada macam ni. Dalam table ni lah, I bagi you faham apa maksud level of significance, the type 1 error. Sometimes we have two condition. First is actual condition. And then this is a decision that we make. Right? So let's say H null is true. True. H null false. H null true. H null false. So let's say decision yang kita ambil, maksudnya kita accept H null. So let's say kita tukarlah, kita tulis accept. Accept and reject. Right? Kita accept H null. When H null is true, maksudnya kalau kita buat keputusan, kita menerima null hypothesis dan actual condition, hypothesis itu betul. So this is a correct decision. Right? Kalau kita reject null hypothesis, right, maksudnya kita reject, maksudnya kalau kita tengok example number page number 82 tu, page number 82, kita kata null hypothesis mu is less than or equal to 8, and then alternative hypothesis mu is more than 8. And katakan kita test the result, right, the data, and kita jumpa memang betul customer serve within 8 minutes. So maksudnya data tu betul lah. And then kita accept null hypothesis and we are making a correct decision. Katakanlah kita jumpa dalam data customer tidak serve within 8 minutes. Sometimes customer serve within 8 minutes. Sometimes, most of the time, customer is serve more than 8 minutes. So, we reject null hypothesis. Kita kata statement null hypothesis tak betul. Kita accept alternative hypothesis, means kita reject. And the actual condition is null hypothesis is false. So, we are making a correct decision. What if we accept null hypothesis, tapi sebenarnya null hypothesis tak betul? So this is what we call as type 1 error. Right? So this is what we want to reserve minimum. Maksudnya kita reserve 0.05, which is only 5% of the condition of the calculation, right? Yang di mana kita accept null hypothesis, tapi sebenarnya null hypothesis tak betul. Right, so kita nak minimumkan dia, kita ambil 5%. So by actually, we need to in the real world, we need to calculate lah for what is the level of significance. And as kalau kita tengok paper-paper yang dipublish dalam untuk yang kalau kita tengok yang current issue is about vaccine kan, AstraZeneca, Pfizer, right? So semua tu dia akan calculate the type 1 error ni dulu. Right, what is the level of rejection area, right? So another condition, when kita reject null hypothesis, maksudnya kita kata null hypothesis tak betul, tapi sebenarnya dalam actual condition null hypothesis ni betul, right? Null hypothesis betul. So we are making type 2 error. Type 2 error. This one type 1 error, the symbol for type 1 error is alpha, type 2 error symbol is beta. Right? So the type 2 error is beta. So 1 minus type 2 error is called as power of the study. Right? So this is beyond our context. Apa yang kita nak tengok, kita nak faham apa itu type 1 error saja. Right? So I don't want to explain more about this. Nanti kalau you minat dalam statistics, then kita boleh explore more lah. And then, step number 3, we need to identify test statistics. test statistics, in this subject, we are focusing on two tests. First is Z test. Another one is T test. Right? So we are dealing with the comparison of the techniques, right? Maksudnya kita akan tengok comparison of data tu. So there are, nanti I explain more about this, right? For this slide, we just want to know the step, right? And then step number 4, we need to determine the decision rule, whether we want to accept the null hypothesis or reject null hypothesis, right? And then we apply the decision rule and draw the conclusion. This is basically step number 5. Okay? Boleh faham? We have basically 5 steps. So, yes. So you need to pay more attention because this chapter is a bit difficult to understand, right? Because we are dealing with inferential statistics. Now, so dalam inferential statistics ni kita akan tengok beberapa test lah, right? First, dalam yang subjek kita ni lah, kita akan tengok one sample. Tulisan saya tak cantik lah. One sample t-test, either on one tail and two tail. Kejap lagi I explain what is a one tail and what is two tail. And we going to test two sample, either one tail. Not one tail. Either independent sample and dependent sample. Kejap lagi I explain what is a dependent sample and what is independent sample. And we're going to learn more than two sample. Means that we have more than two sample, 3 or 4 or 5, right? So this is going to be independent sample. So I hope you jot down the note here. So in this topic, we are focusing on one sample, two sample, and more than two sample. So one sample, we have one tail and two tail. Two sample, we have independent sample and independent sample. More than two sample, we only focus on independent sample, right? So now, so let's look at one sample hypothesis test, right? So one sample hypothesis test, first step is, as I said in slide number, this slide, first step is we need to formulate the hypothesis test, right? We need to formulate the hypothesis test. So to formulate the hypothesis test is by stating null and alternate hypothesis, right? So we need to state what is the null hypothesis and alternate hypothesis. So let me make a conclusion lah, simple conclusion dekat sini. So kalau kita reject null hypothesis, the sample data provides sufficient evidence to support alternate hypothesis. As I said before, kalau kita reject one of the hypothesis, null hypothesis and alternate hypothesis, so let's say mu is less than or equal to 8, mu is more than 8. Kalau kita accept this one, maksudnya kita reject alternate. Kalau kita reject null hypothesis, kalau kita reject null hypothesis means kita accept alternate hypothesis. The other way lah. Sama ada kita reject, kita accept the H null or kita accept H1. Salah satu saja. Right? So now kita tengok type of one sample hypothesis test. So as I said before, we in one sample hypothesis test, we are going to focus on one tail test and two tail test. So one tail test, if you still remember on descriptive statistics, or mean, median, and mode. So we have a normal distribution curve. So this is what we call as normal distribution curve, right? So for normal distribution curve, the center here, right, will be our mean, right? So dalam chapter number 5, you don't really need to remember other type of curve, right? Kita nak tengok normal distribution curve saja. So that's why kita akan tengok two type of test, which is Z test and T test. So Z test is a normal distribution test. T test is also normal distribution test, right? But T test is designed for a small sample, right? Before I go for small sample and big sample, kita tengok tail dulu, right? So for one tail test, right? I highlight guna ni. Okay. So this is the first statement. You nampak? This is the second statement. Dia pair dekat sini. Nampak kalau ada buku, you boleh nampak the pair. Right? So make sure you concentrate on this chapter. Right? And the last one, we have this one. Okay. This is the first one, second, third, and fourth. Right? For the first one, you nampak dekat sini, null hypothesis mu equal to mu naught. So mu naught in this dalam term yang dia pakai dekat sini, null hypothesis, mu is our population mean, right? This is what we call as population mean, right? Equal to mu naught. This is for the first statement, right? Mu naught is some number, right? Represent number lah, mu naught. So maksudnya kalau kita tengok dia boleh jadi null hypothesis mu equal to 8, mu equal to 9. Mu naught ni number, represent number, any number, right? So kalau kita tengok the first one, alternate hypothesis, mu is more than mu naught. Maksudnya mu is more than some number lah. So, untuk determine, remember, listen carefully, this one is very important. To determine whether the test is one-sided or one-tail test, or two-sided or two-tail test, it depends on the alternate hypothesis. It depends on alternate hypothesis. Right? So kalau kita tengok dekat sini, kalau dia more than or less than, conclusion dia, kalau dia more than or less than or more than or equal to, less than or equal to for alternate hypothesis, right? So it will represent one tail test. Okay, Nah, ulang sekali lagi. So kita akan fokus kepada alternate hypothesis. Alternate hypothesis, we look at the symbol that we want to use. Right? So kalau simbol dia more than, less than, more than or equal to, less than or equal to, it will lies under one tail test. Kalau alternate hypothesis is other than, less than or equal to, less than, more than, less than, equal to, more than or equal to, ataupun dia letak not equal to or equal to mu naught, this is what we call as two-tail test. Right. So one-tail test dalam normal distribution, so tengok kat sini pula, dekat graph yang lukis ni, kalau normal distribution, kita nampak dia ada dua tail. This is a left tail. This is right tail. Ni ekor ke kanan, ekor ke kiri. Right? So this is the critical region. critical region. Yang I highlight ni, region lah. This is the region ataupun what we call as rejection region. Right? This is also a rejection region. And this is what we call as acceptance region. Okay. I know this is hard, but if you have a question right now, please raise it now. Ada soalan tak? Hello? Soalan?
Don't have any idea to ask, sir.
Alright. Okay. No worries. Nanti you boleh review back lah. So, this is what we call, dekat rejection region ni, this is what we call our alpha, which is type 1 error ni. Yang ni yang kita nak reject ni. Maksudnya, this is our, yang dekat tengah-tengah ni, yang warna putih ni, acceptance region ni, right? This is our decision, right? If any value lies jatuh dalam rejection region, maksudnya kita akan reject null hypothesis. Maksudnya, apa-apa keputusan kita akan buat ke atas null hypothesis. Dan kita akan test null hypothesis. Bukan kita akan test alternate. Remember, so maksudnya, kalau kita punya value nanti kita akan kira, dia termasuk dalam rejection region, right? So, kita akan reject null hypothesis. Kita accept alternate hypothesis. So, now, as I said just now, apa-apa keputusan kita nak tengok untuk one-tail test, kita akan tengok kepada alternate hypothesis. Right? So, dalam distribution curve ni, dia start from, the left ni, dia start from negative infinity to infinity. This is the statistic part. Right? It start from negative infinity to infinity. Maksudnya, this is just a symbol lah. Maksudnya, this is the smallest value to the largest value. Right, to the largest value. Means, kalau mu is more than mu naught, maksudnya dia akan right hand side. Maksudnya, dia akan ke right hand side lah. This is when alternate hypothesis mu is more than mu naught. Alternate hypothesis mu is more than or equal to mu naught. Right? In this condition. This is the right tail. Kalau alternate hypothesis is less than mu naught, ataupun alternate hypothesis is less than or equal to mu naught, it means that it stay to the left, right? So kita akan draw the distribution and critical region rejection area kita to the left, right? Remember, right? For two-tail test, kita akan consider dua-dua side, two-sided. Maksudnya, on the right hand side and on the left hand side, dua-dua. Kalau two-tail test, this is very simple, right? For the most crucial thing that you need to understand is for one-tail test lah, whether we want to decide what sided yang kita nak ambil. Kita nak ambil right-sided or left-sided. Okay, so this is the total alpha. And this is the area of alpha divided by 2. And this is area alpha divided by 2. Maksudnya, let's say, the two-tail test ni dia akan share lah. Maksudnya 0.05, dia akan share 2. 0.025, 0.025. Right. Okay, boleh So, now. So, this is what I said before lah. If the null hypothesis is false, we fail to reject. Null hypothesis is type 2 error. Right, ini benda yang sama lah yang tadi I terangkan dekat Sini, right? Benda yang sama di dalam page number 81, right? Okay. Now, this is step number 3, page number 81, right? Okay. As I said before, to select a test statistics, right? Statistic without S, nampak kat sini, test statistic. Step number 3. Right? Test statistic is a value determined from a sample information used to determine whether to reject null hypothesis or accept alternate hypothesis. Test statistic used depend on type of hypothesis. So we have two type of test statistics. First is Z statistics. Another one is T statistics. Right? So, how to determine which test to use? Right? So, kita nampak dekat sini, sigma squared or sigma. Means that population standard. Oh, tulisan I tak cantik lah pagi ni. Population standard deviation. So, it's all start with population standard deviation. If the population standard deviation is known and unknown, right? If the population standard deviation is known, we straight away use Z distribution, Z statistic. If the population standard deviation is unknown, we have two conditions, right? Either N or sample size is less than 30 or sample size is more than 30. This is just a simple rule lah. This rule what we call as a central limit theorem. But less than 30 ni is not, dia still ada perdebatan kat situ. Right? Tapi I tak nak terangkan lebih. Boleh lah terangkan lebih. Tapi 30 tu, when you take from a very normal distribution lah, very normal sample. So sometimes in the book we say more than 100, more than 500, more than 1000 to be considered as a central limit theorem. Right? Central limit theorem means that we want to assume that the data is normally distributed. And of course, either T distribution or Z distribution, both should consider from a normal distribution jugalah. Tapi dekat sini dia ada dua condition. If N is less than 30, use T statistic. If N is more than 30, use Z statistic. So Z statistic, the formula is Z equal to X bar minus mu divided by sigma over square root of N. Right, this is the formula, right, for Z statistics. For T statistics is X bar minus mu divided by S over square root of N. Right? Boleh For Z statistic, when N is more than 30, so sama juga dia akan pakai Z statistic lah. Tapi Z statistic formula, but we replace sigma into S lah. We need to calculate the special formula. Right, but we are not focusing on Z statistic more than 30 sample lah. Sorry, I terbalik dekat sini. I terbalik. Sorry. I terbalik. When N is more than 30. When N is less than 30. So when N is less than 30, use Z statistics. When N is more than 30, use T statistics. When the population standard deviation is unknown. Right? So nanti I akan tunjuk the p-value approach, right? Sekarang ni kalau I terangkan pun you tak berapa nak faham. And step number 4, yes.
Nak tengok balik formula tadi tak sempat tanya.
Okay.
Yang tidak.
This formula is in page number 81. So you need to know the formula because we want to apply, we're going to calculate the value of Z statistics into our Excel. Alright, step number 4 and step number 5 is the same repetition from a previous slide. Alright, step number 4 is we need to determine the decision rule. Alright, and then step number 5 we're going to draw a conclusion. Alright, nanti I tunjuk dekat you lah. And this is the Excel function, right? That we're going to use to calculate the value of T statistics and hypothesis testing lah. Right, so this function are available in page number 82. Right, so I hope you all already have the book, kan? Ada yang tak ada buku lagi? Ada yang tak ada buku? Raise your hand. Ada? Semua ada. Alright, good. So you can refer to page number 82. Right? Page number 82. But tapi macam I cerita dekat sini, right? Dalam buku dia tak tulis macam ni tau. You need to, this one I already summarize to you. So make sure you take note about this lah. Ini senang you nak nampak. Right? Kalau you I tak buat macam ni, you tak faham macam bila nak pakai, right? Right, so now kita tengok example number 1. Okay, example number 1, we going to use where is it, data set, Inferential Statistics. Right, I hope you already download the data from UFuture. Semua data ni kita akan gunakan fast food restaurant customer waiting time 1. Right, so make sure you download the data and open the data. So this is the data, right? So we have basically berapa data ni kita ada? We have 50 data. Right, so 50 data. Okay, now before we try to answer the question, kita tengok soalan dulu. So a fast food restaurant claims that the customer order will be served within 8 minutes of placing an order. The manager of the restaurant received complaint on waiting time. So the manager collect 50 customer waiting times in minutes in the Excel, fast food restaurant customer waiting time. So dia kata dekat sini at 0.05 level of significance using the critical value approach and p-value approach. Nanti I akan terangkan sambil lalu for the hypothesis testing. Is there evidence that the sample mean waiting times to place an order support the claim made by the restaurant? So now, first step is we need to create hypothesis statement. Remember dalam test nanti kena buat macam ni lah. Null hypothesis mu is more than or equal to 8. Sorry, they claim apa? Apa yang they claim? Will be served within 8 minutes kan? Mu is less than or equal to 8 lah. Alternate hypothesis, mu is more than 8 minutes. Right, sama ada dia dalam 8 minit ataupun lebih daripada 8 minutes. So this is our hypothesis statement, step number 1. Step number 2, right, I tulis kat tepi lah bagi nampak besar sikit. Alright, ke bawah ni letak kat sini. Oops. The hypothesis statement. This is step number 1, hypothesis statement. Step number 2, we need to state the level of significance. So alpha is 0.05. Mana you dapat alpha 0.05? Dia dah bagi tahu dekat sini. Alpha 0.05 at 0.05 level of significance using a critical value and p-value approach lah, right? Okay, so this is how we going to test the statement. So step number 3, we going to select a test statistics. Test statistics. Test statistics dekat sini yang kita akan guna adalah t-test, right? Sebab apa? Sebab dalam condition data value ni, right, kita tengok balik nak fahamkan soalan kan. Okay, dalam soalan ni dia tak bagi tahu kat kita the population variance. The population variance is unknown, right? Remember step ni, population variance unknown. So kita tak tengok dekat sini. Dia kata kalau unknown, tulis ni, kalau n is more than 30, kita akan guna t-test. When n is less than 30, we want to use z-test. So we look at the data. The data that we have kat sini I letak n, bagi besar sikit lah, so nampak sini. So I letak n, so I tekan count. I nak kira lah berapa data yang I ada, right? So I ada 50 data, right? Boleh So this is a customer number and this is the time. Customer number 1 dia tunggu 8 minit, customer number 2 tunggu 7 minit, customer number 3 tunggu 9 minit. So overall data we have 50 data. So once we have 50 data, more than 30, so we going to use t-statistics. Boleh Boleh faham kat mana I guna test ni? Right. So we going to use t-statistics. So t is equal to x bar minus mu divided by s over square root of n. Right. So now is the time that we are going to calculate t value. So we go to our Excel file. So apa yang kita nak kira, kita dah tahu dalam Excel file ni kita kena ada kita tengok formula t is equal to x bar minus mu divided by s over sigma n, square root of n. So based on the formula ni, kita dah ada value of n. Kita kena to calculate value of n. And of course we need to know our alpha. Alpha is 0.05. Right? Our alpha is 0.05. Wait, I tukar this one to Calibri. Okay. And then our mu, let's say I insert the formula. Mu is so our mu kita apa? Kalau kita tengok this one, our mu is equal to 8, less than or equal to 8, right? So kita nak test our mu sama dengan 8. So here our mu is equal to 8. So kita letak 8 kat sini. Boleh? And then dekat sini apa kita ada lagi? Dia ada x bar, mu, n. Yang ni kita dah ambil, mu kita dah ambil. X bar apa dia? Still remember last lecture? What is the meaning of X bar? X bar means the average waiting time. Average waiting time. So how to calculate average waiting time? So last lecture, remember average, right? From B4 until B53, right? Okay, B4 to B53, right? So this is the average waiting time. So this one, X bar pun kita dah ambil. So kita dah ambil this one, kita dah ambil this one, kita dah ambil this one. And kita nak cari S. S ni apa? Standard deviation. So standard deviation, STD. Remember last lecture, STD EAV dot S. Ini standard deviation for sample, right? B53. So standard deviation for sample we got 1 point berapa? 1.3. Saya letak kat sini sekejap. Okay. 1.34756, right? Right. Kalau kita tengok dekat sini, dia ada square root of n. Kita ada n, but we need to calculate the square root of n. So kita letak square root of n. So square root of n, SQRT, n dekat sini 50 kan? Okay, select. So we got 7.01, 071, right? Now, since we already have all the value here, then we can calculate the t value. So t statistics. T statistics tak boleh padam kat sini. Okay, tak apalah. T statistics, tulis balik bawah. T is equal to x bar minus mu divided by s over square root of n. So now, kita letak sama dengan, kita nak buat yang atas ni dulu. Yang atas, x bar, which is 8.02 minus mu, which is equal to 8. And then, we divide kurungan dekat sini, S, which is a standard deviation, divide by square root of n, which is square root of n kat sini. Dan kita akan dapat 0.104946. This is as a t statistics. So now, once you already got the value, you just plug in the value dalam, dekat sini lah, 0.10495. Right. Boleh ikut setakat ni. Baru step number 3. Boleh semua dapat You want me to show the formula? Okay, good. Good. Alright. So I think this is very simple kan? Okay. So now, kita pergi ke hypothesis test statement kita ni. We already have the statement, null hypothesis and alternate hypothesis. Alpha is equal to 0.05 and step number T is test statistics. We already got the test statistics. Step number 4, critical value. Ataupun kita panggil critical region. Kita nak draw the critical region and we want to calculate the critical value. So now, let's look at the alternate hypothesis dekat sini. As I said just now, when mu is more than 8, so dia akan dapat one tail test. Remember slide tadi saya ulang banyak kali ni. Okay, ni Kalau null hypothesis, alternate hypothesis is more than, less than, more than or equal, less than or equal to, so dia lies under one tail test. Kalau dia more than dekat sini, alternate hypothesis more than or equal to, so dia akan right hand side. Kalau less than, left hand side. Right? Sebab apa? Left hand side ni lebih kecil, right hand side dia lebih besar. Itu senang nak ingat kan? Alright, so we move to the okay. So now we are look at the alternate hypothesis. We know that the mu is more than 8. So we need to draw the region. We draw the curve dulu. And then this is your mean. Right? Which is your 8.02. And it lies on the right hand side kan. So this is more than 8. So this is the area dekat sini. Yang ni kita nak cari ni. This is a critical. Allah. This is the critical value. So the critical value, this is going to be alpha equal to 0.05. Okay. The critical value here will represent T alpha alpha equal to 0.05 with the degree of freedom. This is the T value. The T value means the critical value. This is what we call as critical value. The formula is T alpha 0.05 with the degree of freedom. So what is degree of freedom? So degree of freedom, or the notation is df is equal to n minus 1. So in our example, n minus 1, n is equal to 50 minus 1 equal to 49. So next, what we need to do is, we're going to calculate the degree of freedom. So degree of freedom is n minus 1. So n minus 1, which is equal to 49. Right? And then we're going to calculate a critical value. So there are several methods, right? Since we sometimes we most kalau dalam statistical punya topic, I will show how to use a statistical table. But since we are using a significant Excel, right? Kita tengok balik nota yang I bagi dekat sini, okay. Dalam page number 82, I think, right? 82. So this is the formula that we're going to use. So nah, kita tengok find critical Z value, find critical T value, critical T value, critical T value, and these all are P value kan. Okay. Kita akan fokus kepada 4 ni. Alright. So, now critical Z value tak ada kena mengena sekarang. Sebab kita menggunakan T-test. Right. So, kita akan fokus pada 1, 2, 3. Find critical value for one-tail test. One-tail test. This is two-tail test. So, ini tak termasuklah dalam kita punya pencarian sekarang. So, kita akan tengok ini and ini. Right. So, dia kata kat sini, right tail. This is for left tail. So, our test now is for right tail kan. So, di sebelah kanan. So, we're going to use this formula lah. We're going to use T dot inverse INV alpha n minus 1. So our critical value equal to T dot INV, right? Alpha, first kita kena masuk the probability value which is our alpha, and then the degree of freedom. Nah, dia kata kat sini degree of freedom. So letak degree of freedom. And they will give us the value. Betul tak? Yeah, for right tail test, dia terbalik kat sini. Sepatutnya I salah tulis. No, I terbalik kat sini, okay. This is not alpha. Terbalik. This sepatutnya dekat sini for a right tail. This is for left tail. Maksudnya for a right tail, it should be t dot inv 1 minus alpha n minus 1. For left tail, it should be t dot inv alpha n minus 1. This is correct lah. So kita tengok dekat sini, dia dapat negative, which is not really correct. So we need to letak kat atas alpha tu 1 minus, right? Then baru kita akan dapat 1.676. So 1.676 is dekat mana? It's supposed to be here. This is the value of 1.67. Apa tadi? 1.676. 676. Ataupun 1.677 lah. Benda kalau kita gundakan kepada, tak apa, kita letak 4 lah. 6765. Right. Okay. This is the critical value. Boleh faham? So, based on the critical value, okay, this is a very important. Listen carefully. Step number 5. We're going to make a decision rule. Right? So, before we make a decision rule, we need to understand that in this area, on unshaded area ni, the whole area is what we call as acceptance area. This is what we call as rejection area. Okay? Boleh? You just need to understand this one. So, if the T statistics is more than 1.6765, which is the critical value, H null is rejected. If T statistic is less than 1.6765, null hypothesis is accepted. So, step number 6, we're going to make a decision. Our decision, since T statistics equal to berapa? T statistics is equal to 0.104. 0.10495, is it? Right? Is less than 1.6765, right? Maksudnya 0.1 ni dia ada dekat sini, somewhere here, 0.106749 kan, dia dekat sini. Maksudnya dia dalam acceptance region, dia bukan dalam rejection region. So, since T statistic is less than 1.675, so we accept null hypothesis. And step number 7 is make a conclusion. So, we have 95% confidence that the waiting time, the average waiting time is less than 8 minutes. Sebab apa? Kita accept null hypothesis. So null hypothesis is less than or equal to 8 minutes. So we have 95%. Kat mana main 95% ni? Because our alpha we reserve 5% error. We are confident 95% confidence that the average waiting time is less than 8 minutes. Okay, boleh faham tak? Ada soalan tak? Before kita masuk p-value punya konsep. Hello? Soalan? Yes, sedikit susah nak faham. But this is very tough subject, right? Topic. So you need to revise back and baca balik banyak-banyak kali. This is the concept of hypothesis statement lah. Right? So don't worry if you don't understand now. Just ask me a question. Kat mana you tak faham. And then ataupun you boleh tengok balik video nanti petang nantilah.
Sure.
Yes.
Can you please reverse to calculation of p-value? I need to see the formula.
Calculation for p-value. Belum masuk p-value lagi?
T-statistic, sorry.
T-statistics. T-statistics
Yes.
dekat sini lah. This is the formula of T-statistic. X bar minus mu divided by S, which is a sample standard deviation, divided by square root of N. So, apa yang kita buat? Kita ambil, buat kurungan. Kita ambil X bar dulu. X bar adalah average waiting time. Minus D6. D6 is our mu. Mu is 8. And divide by kurungan S. S is our standard deviation. Divide by square root of N, which is square root of N here. Okay?
Okay, sir.
Right. So now, we already learned the concept of critical value. Right? Critical value. So, there another concept that's very simple and most of the software are using this concept. But basically, this is the original concept. Critical value is the original concept and the classical concept. Right. For the modern era concept, which is sometimes dia ada beberapa argument dekat sini. Dia ada concept of p-value. Since p-value ni maksudnya kita punya alpha is 0.05. Alpha is 0.05. If the p-value less than 0.05, we will reject null hypothesis. This is the decision rule if to use p-value. If the p-value is more than 0.05, we will accept null hypothesis. So this is the rule. Right? This is first rule, second rule. Okay. So now, let's look at the formula again. Right. Okay, dekat sini critical value, but now we are focusing on the p-value. P-value, 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 p-value. Right. And p-value for one-tailed test and right-sided test. Right. So this is the p-value for right-sided test T-statistics. So we're going to calculate using 1 minus T distribution n minus 1 and the argument is true. So kita letak dekat sini p-value. So equal to 1 minus T dot distribution. Right. So apa yang dia nak dekat sini? Nilai value T. So kita cari T statistic kita. Letak sini T, comma. And we need to input the degree of freedom. Degree of freedom. And the last one is true argument. Means that we're going to use a cumulative distribution function instead of probability density function, right? Sebab apa cumulative distribution function? Sebab kita menggunakan cumulative lah, right? So now kita nampak kat sini p value is 0.4584. So dekat sini benda yang sama juga, right? Benda yang sama, cuma dia lebih shortcut, right? Berbanding dengan critical value. So now kita punya p value. Let's say I guna pen color hijau. P value 0.4 apa 0.4584, right? So apa yang kita letak kat sini, if the p value is less than 0.05, which is our alpha here, this is our alpha, we will reject null hypothesis. If the p value is more than 0.05, which is now our p value is more than 0.05, we will accept null hypothesis. So the conclusion still remain here lah, still remain sama juga. So since the p value is more than 0.05, null hypothesis is accepted. So the conclusion still remain sama lah. So kalau kita tengok the concept of critical value dengan konsep of p value, dia tidak akan bercanggah. Dia semua sama saja. Sebab ini p value means kita convert the t distribution tu kepada probability value. And critical value, we still use a concept of t distribution, but we are using cut-off point 0.05. Benda yang sama lah. Right? Conclusion dia akan dapat yang sama. Okay? So how we interpret is different. Right? So this is the decision rule. Nampak dekat sini, decision rule for critical value, and this is the decision rule for p value. P value, critical value. Right? Boleh Ada soalan tak? Soalan? Hei manusia. Right. So example number 2, page number 85. So administrative office of a hospital claimed that on weekend the mean waiting time for emergency ward visit is 15 minutes, right? So dia kata dekat sini, they claim that on weekend the mean waiting time for emergency ward is 15 minutes. For a random sample of 40 patients who receive treatment in the emergency ward of this hospital shown in Excel, weekend emergency ward waiting time. So you buka weekend emergency ward waiting time. So you download the data set from UFuture, and then dia kata dekat sini, test whether the mean waiting time at emergency ward is different from 15 minutes at 5% level of significance. So what can we understand here? First, we need to write down hypothesis statement. So our hypothesis statement, null hypothesis, mu is the claim dia kata dekat sini, waiting time for emergency visit is 15 minutes. So sama dengan 15 minit. Right? So alternate hypothesis. So we want to test whether the waiting time MGT is different from 15 minutes. So mean is not equal to 15 minutes. Right? So from this hypothesis statement, we already learned here, when the alternate hypothesis is not equal to, so we're going to have a two-tailed test. Okay? So we know that our test is going to be a two-tailed test. So second step is we need to set a significant level, which is our alpha equal to 0.05, which is 5% lah, significant level. And step number 3 is test statistic. So what is our test statistics? From this example, we don't know the standard population standard deviation. We don't know the population standard deviation. Since we don't know the population standard deviation, right, it will lies under unknown. Right? When the sample size is more than 30, we're going to use T statistics. When the sample size is less than 30, we use Z statistics. So since the sample size is more than 30, which is 40 sample, right? 40 sample. So we're going to use T statistics. T statistics is equal to X bar minus mu divided by S over square root of N. Okay? For this statement, we know that N equal to berapa? 40 kan? Dia kata kat sini. N equal to 40. N equal to 40. And our mu equal to 15. 15 minutes. And our X bar, we don't know. Our alpha is equal to 0.05. Right? So now what we need to do is we need to go for our Excel file. Our Excel file, we need to state our N equal to count all the numbers, right, from B4 to B43. B4 to B43. And our alpha equal to 0.05. Right? Our mu is equal to 15 minutes. Right? This is all the information that we have now. So what we need to do next is we need to find our average waiting time. Average waiting time is equal to average from B4 to B43, which is equal to 16.45, right? And then still remember the formula require us to find the square root of n. Square root of n is SQRT. Our n is equal to 40, and we close the bracket. We got 6.32456. Next, we need to find the standard deviation. Standard deviation of sample. So standard deviation of sample, STDEV dot S from B4 to B43, which is equal to 2.24, right? Next, we need to find the T statistics. T statistic without S, means this is the sample. or this is what we call as a numerical value lah yang kita nak test, right? So numerical value, so we need to bracket x bar minus mu. Our mu is equal to 15 divide by standard deviation. Oh sorry, I letak ke bracket lah baru senang. Standard deviation, where is the standard deviation? Okay, standard deviation E9 divide by square root of n, which is equal to 4.0917. So this is going to be 4.0917. And then next step is we need to find a critical value and region, right? Since this is a two-tailed test, because the alternate hypothesis is not equal to, right? So we draw a bell-shaped curve. This is x bar, and we're going to have two-tailed tests on the left-hand side and right-hand side. So our t statistics is lies, let's say kita letak mean equal to 0 dekat sini, right? Sebab kita nak convert ke standard normal distribution. Standard normal distribution, the center should be 0. This is from negative infinity to infinity. This is a t value, right? So t value should be lies from 4.09 lah, somewhere here lah, kan? So different with the difference between one sample t-test and two sample t-tests. Sorry, one sided and two-sided. For one-sided, this whole area would represent alpha 0.05. But for two-tailed test, this area on the right-hand side ni, right? I hope you understand. So this area alpha equal to 0.05 divided by 2. This is alpha equal to 0.05 divided by 2. Because our alpha is 0.05, we shared by two-sided. So we need to divide equally for left-hand side on right-hand side. Sama juga. So alpha will be 0.025. 0.025. This is alpha divided by 2 lah. Right? Okay, boleh. So now we need to find the critical value. So this critical value is T alpha divided by 2 with degree of freedom. And this area is T negative alpha divided by 2. Sorry, it's not negative T. This negative T alpha divided by 2 with degree of freedom. Basically, these value are the same value, but on the right hand side, it should be positive value. On the left hand side, it should be negative value. Right? So now, by looking at this formula, so we are focusing on critical value, right? So on basically we are focusing more on two-tailed test. So two-tailed test, the formula would be t.inv dot two-tail dot 2t alpha n minus 1. So this is the formula for critical value. So now we just plug in the value. Critical value should be equal to t.inv. So dekat sini dia akan keluar dua lah. Bagi dia perasan kan. T.inv, satu lagi t.inv dot 2t. So you tekan 2t dan you tekan tab. Right. So the requirement value is the probability value and the degree of freedom. The probability value here will represent the t value. The probability value should represent the alpha lah, alpha. Bukan, dia kata T value lain. This is alpha. And then followed by n minus 1, which is our degree of freedom. Oh, tadi kita lupa nak calculate degree of freedom kan? Okay, degree of freedom will be n minus 1. Right? So it will be 2.022. So dekat sini kita boleh tulis this one should be ambil pen color ni. This is 2.022 and this is going to be negative 2.022. So this is the area. This is the critical region. So what does it mean here? This is acceptance region. And this is rejection region. This is also a rejection region. Right? So now, since we already calculate the critical value, we need to make a decision rule. So what are our decision rule? Our decision rule, let's say I make color hijau balik. Decision rule. So if T statistic ni is more than 2.022 or T statistic is less than negative 2.022, means that this value lies under rejection region. So null hypothesis is rejected. Okay. So since since T statistics is equal to 4.09, is it 4.09? So which is more than 2.022, which is the first condition. Null hypothesis is rejected. So we're going to reject null hypothesis. So conclusion, we can say that we have 95% confidence that the waiting time is not equal to 15 minutes. Right, itu saja. Okay. So, what if we use a p-value? So, p-value for two-tailed test dekat sini. This is the p-value for two-tailed test. So, we can use either one. So, if t is more than 0, so we're going to use t dot distribution two-tailed n minus 1. Kalau t value is less than 0, kita akan letak negative t. So to differentiate which side the p value should cover. Right? So since our t is more than 0, so we're going to use the first formula, the p value. So sebelum tu I letak degree of freedom kat sini. Degree of freedom. So degree of freedom is n minus 1. Right? So the p value will be t dot distribution. Kita akan ambil two-tailed test. Right? And then kita akan input t statistics and our degree of freedom. So then we will get 0.0021. 0.0021. So kita letak kat sini. Dia benda yang sama je. Dekat sini. Kalau kita tak guna critical value, kita menggunakan p value. So p value is equal to 0.002 to berapa? 0.00021. Okay, ada 3 0 kat sini. 0 to 1. If the p-value, and this is a decision rule, less than 0.05, null hypothesis is rejected. So this is the decision rule, right? So since p-value is less than 0.05, which is 0.00021, is less than 0.05, then null hypothesis is rejected. So the conclusion will be the same lah. Okay, boleh So this is for example number 5.2, page number 85. Any questions so far?
So nak tengok formula p-value dekat Excel tu.
Formula p-value dekat Excel, okay. Kita pakai t.distribution.toTail and D1 ni adalah T-statistics, which is D11 ni, D11, this one. And then we comma, kita letak degree of freedom. Boleh Kenapa kita pakai ni? Sebab the T statistics, the value of T statistics is more than 0. Right? Sebab dia lebih daripada kosong, kita pakai this formula. Kalau dia kecil daripada kosong, maksudnya kita akan letak negative D11. Itu saja. Right? Okay So anything for the formula, you rujuk balik page number 82. Page number 82, right? Page number 82, semua formula ada kat sini. Benda yang sama. Okay? So for one proportion ni, I akan skip dulu. Nanti I buat video lain. Right? We have only another 15 minutes kan? Example number 3, kita skip dulu. Nanti I buat video, separate video for next week. I akan letak dalam future. And before we end, sebenarnya I nak tunjuk lagi 3. First is sample proportion, 2 sample t-test, and then we have independent sample t-test, paired sample t-test, and one way ANOVA. Ada 6 example. So kita dah cover 2 example, 2 test yang kita dah tengok. Right? So I think okay lah, apalah, I tunjuk one sample proportion dulu lah. Yang for 2 sample t-test, independent sample t-test, paired sample t-test, and one way ANOVA, I tunjuk dalam separate video. Okay, boleh So we don't have much time. If you are willing to stay, then I akan tunjuk semua lah. Maybe it will take some time sikit lah. Are you okay with that? Or you want me to post a video?
I think better on video, sir.
Okay, good. So now, last example. Right, last techniques, which is one sample proportion. Right? So now, one sample proportion is a bit different on what we have learned just now. Proportion means that we want to know how many percent. What is the proportion? What is the percentage? What is the probability? Pecahan dia berapa? So many key business measures expressed in terms of proportions such as sales growth, market share, product return rate, customer acquisition rate. So they give on the rate value, means the on the ratio value, on the rate value, percentage value. So thus it often to conduct a test hypothesis about a proportion of the population. So the hypothesis testing for the population proportion is similar to testing for population mean, right? Dia similar saja, sama saja, right? Cuma perbezaan dia kita kena kira sikit. Right, sekejap saya tunjuk. Page dia kita akan menggunakan express computer delivery time. Mana DP? Oh, saya tak boleh buka. Kejap. You boleh buka ke express computer time tu? Okay, I boleh buka dah. Right. Okay. Right. So, for proportion, kita akan menggunakan z-test. So, z-test, z is equal to p hat minus p divided by square root of pq divided by n. Right? Okay? Hey, you all okay kah? Ataupun you dah pening dah? Kalau you pening, I stop lah. Maybe next slide, I post dalam next video. Kalau you okay, I will teruskan kat sini.
Pening, sir.
Pening. So you want me to stop? Okay, don't worry lah. So I stop here dulu sebelum so kita ada one proportion, two sample t-test, paired sample t-test and one way ANOVA. Basically untuk test yang akan datang ni, example 3, 4, 5, 6 ni, I akan tunjuk dalam separate video lah. So I tak nak bagi burden dekat you hari ni. So basically you need to understand the concept first, right? Yang first, I ulang balik sebelum kita conclude the session. First, kita tahu statistik ni ada dua type. Descriptive statistics, which is we already learned on last lecture. And this is a inferential statistics. So dalam inferential statistics kita nak tengok hypothesis testing, right? So dalam hypothesis testing kita ada null hypothesis and alternate hypothesis, right? Oh, nak masuk dalam data dan Excel tu very simple saja. Just tengok buku macam mana nak buat, itu saja, simple, right? And then we need to understand how to write, follow the steps saja. Ada 5 step ni. Formulate hypothesis statement. Kita tahu dia punya level of significance. Identify the statistical test is very crucial. Right? Mana statistical test yang saya tulis tadi? Statistical test kita kena identify. Once kita dah identify statistical test, calculate the critical value ataupun p-value. You need to understand both. Right? And then we need to make a decision and conclusion. Itu saja. And then the how to use Excel function is very simple saja. Tak susah pun. And the most important part is concept. If concept tak faham, yang ni semua tak boleh faham. Yes. This is quite advanced lah. Ni untuk degree kan. Okay. Alright. So I think I stop here untuk inferential statistics. So for this seminar kita stop dekat sini, and then nanti lepas ni maybe tomorrow I can make a video on one sample proportion, two sample t-test, one independent sample t-test, pet sample, and one way ANOVA. Okay?